Sustainable Sites 2009, including notes on updates for LEED version 4 based on the draft 4 comment review. Sustainable Sites. This webinar covers Sustainable Sites section of LEED version 3 with notes on version 4 based on the draft 4 comment period. Sustainable Sites prerequisites and credits are the second most heavily weighted section of LEED. Sustainable Sites intention covers projects sensitivity to agricultural and prime farmland, preserving natural ecosystems, impacting existing wildlife as little as possible, the limit of automobile use based on location, which therefore reduces carbon footprint, which was seen as one of the top priorities in the reweighting of LEED 2009, version 3, and not adding erosion and sedimentation to waterways. The Dirty 30s is a good example of why it's so important to pay attention to our sites and the bioregion and how they function. During the Dirty 30s, our first industrial revolution, we overcropped, didn't pay attention to the natural prairie grass, which has large acres and can handle the large wind flow coming through those prairie areas, and created our own dust bowl. Had huge economic impact on this country. The first prerequisite in this section is construction activity pollution prevention. This is required for new construction, schools, and core and shell. The requirement is an erosion and sedimentation control plan, or following local codes if they're more stringent. The standard you need to know is the EPA Construction General Permit, including provisions of the National Pollutant Discharge Elimination System program. In LEED version 4, based on the version 4 draft comment review, that standard goes from 2003 to the 2010 version. Definitions you need to know are erosion, soil being moved by stormwater, runoff, or wind; sedimentation, addition of soil to storm sewers and streams; turbidity, reducing sunlight that triggers photosynthesis in aquatic vegetation, which supports aquatic life; and eutrophication, the increase in chemical nutrients found in fertilizers that cause excessive plant growth and algae blooms. I grew up on a houseboat, and I have seen these in real life, and it is not a pretty picture. Related credits, otherwise known as synergies, include SS Credit 5.1, Site Development, Protect or Restore Habitat. Also, Site Development, Maximize Open Space through site restoration to prevent erosion and sedimentation, including this prerequisite. Stormwater design, quantity, and quality control by preserving sites' natural hydrology. Two methods for implementation include stabilization. This could be in the form of temporary seeding, permanent seeding, or mulching to hold in moisture. So there's another synergy with stormwater quantity control and also water efficient landscaping. Structural control would include earth dike, silt fence to hold back contaminants, sediment trap, or sediment basin. In the design phase, could be a civil engineer or landscape architect in the LEED. But take note, in LEED version 4, there's a new integrated process section in the beginning of the LEED rating system for new construction that include all team members working together to solve these issues to make a more sustainable development holistically. During this time, you want to identify erosion-prone zones and compare local codes to LEED requirements. In the construction phase, the general contractor will probably be the prime lead in this responsibility for this prerequisite. They'll need to know how to implement the erosion and sedimentation control plan and keep date stamped photos and inspection logs and maintain control measures throughout the construction until the site is stabilized. Taking photos comes up again in an environmental quality credit for construction management, indoor air quality management. You also need to develop an erosion and cementation control drawing that includes specifications of the best management practices and a list of responsible parties. Over the course of the site work activities, you'll need, once again, the date stamp photos, inspection logs, or reports of corrective action in response to problems. So once again, not just listing problems, but also how you are going to correct those problems. A second prerequisite is environmental site assessment. This is mandatory for schools only. It includes a Phase 1 environmental site assessment based on ASTM standards, often required by lending agency or local codes anyways. So this may not be an additional requirement, but you need to check and make sure that you meet the prescriptive LEED requirements. You'll need to conduct a Phase 2 environmental site assessment if contamination is suspected. In this case, collect original samples of soil, groundwater, or materials to analyze presence of contaminants. In LEED version 4, there's added guidance for projects outside of the U.S. Something that's unique to schools is that a site that was ever a landfill cannot be a LEED certified school. It can be contaminated in other ways as long as it never served as a landfill, because kids are more sensitive to type of chemicals and things that can impact that site. And the environmental site assessment needs to meet EPA Region 9 cleanup standards and provide documentation from authority that safe levels of contamination have been achieved, otherwise known as the EPA's Ready for Reuse document. In the implementation phase, you want to contact the Regional EPA Office of Solid Waste and Emergency Response, which may provide remediation support as well. So you'll review historical records, visit the site to identify potential hazardous substances, interview people who know the site, report documenting the results of the analysis, and in this documentation phase, provide executive summaries from all ASTM site assessments performed, provide a description of remediation efforts if needed, and documentation from the governing authority that shows the remediation has met those standards. Site selection is the first credit in the Sustainable Sites category. 1 point is associated with achieving this credit. The intent is to avoid development of inappropriate sites and reduce the environmental impact from the location of a building on a site. The standards include FEMA, U.S. Department of Agriculture, Code of Federal Regulations, and the Clean Water Act to make sure you're avoiding those sensitive areas. In fact, LEED version 4, draft 4, renames this credit sensitive land protection in the location and transportation section that would be added to LEED version 4 based on this draft period. Site selection, the prohibited development criteria include prime farmland, previously undeveloped land use whose elevation is lower than 5 feet above the 100-year flood, habitat for endangered species, development within 100 feet of any wetlands, previously undeveloped, which means not altered by human activities, land that is within 50 feet of a water body. Ponds made from stormwater and recreation are exempt. Public parkland is also prohibited unless an equal trade is arranged. The benefits of being sensitive to site selection is protecting natural areas. You can do this by limiting the building footprint. This is something that you'll see that shows up in multiple sustainable site credits, meaning it's a very important sustainable design strategy. You can also integrate with natural surroundings. That could be bringing in a big stone or plantings into a building. Frank Lloyd Wright was known for this. He would actually make something the heart of a home. And for schools, by connecting to the outdoors, you can show how the built environment is connected to their larger ecosystem. Related credits for the site selection credit include development density and community connectivity, so that limiting the building footprint can lead to more density. Brownfield redevelopment, by avoiding prime farmland and undeveloped green spaces, you're more likely to develop on a brownfield, possibly an infill site, which is more heavily prioritized in LEED version 4, proposed at this time in draft comment period 4. Alternative transportation and public transportation access, due to the fact that this is encouraging more urban sites. Site development, protect or restore habitat, and maximizing open space, and also stormwater design quantity and quality control. Stormwater quality and quantity control is very important by waterways. Development density and community connectivity is the second credit in this section. It's more heavily weighted. 5 points associated with new construction, 4 points associated for schools, and 5 points for core and shell projects. The intent is to channel developments to urban areas with existing infrastructure and protect untouched greenfields, therefore preserving habitat and natural resources. In LEED version 4, draft 4, it's renamed in the location and transportation section to surrounding density and diverse uses. Multiple thresholds for density are included, and you can earn points with both options. Option 1 in version 3 is development density. It includes previously developed site with a minimum density of 60,000 square feet per acre net, which is a typical 2-story downtown approximately. Schools with fields and sporting event facilities are excluded. Implementation for option 1, you'll determine the development density of the project site, determine the densities of surrounding developments, calculate the density radius, overlay the density radius on a site map originating from the center of the site, include any properties that intersect the density boundary, as you will see on the next slide. This slide is to calculate the density radius that's going to set that boundary. This example is for a 30,000 square foot building located on a half-acre urban site. First, you must calculate the density of your site based on square feet per acres, which is 30,000 square feet per 0.5 acres, which equals that minimum 60,000 square feet per acre. And to calculate the density radius, it's 3 times the square root of the total site acres times 43,560 square feet per acre to convert those acres to square feet. The purpose of the square root is not just to make a difficult math equation, but it actually serves a purpose to remove effects of a site shape. In this case, the density radius equals 443 feet, and that is how the density radius will be drawn around a site. Community connectivity is option 2. So previously developed site is also required. The additional requirement is that within a half mile of a residential zone or neighborhood, there's an average density of 10 units per acre net, or within a half mile radius of 10 basic services with a pedestrian route: restaurant, bank, grocery, laundry, etc. The only basic amenity that can be counted twice is a restaurant. In order to implement this, you need to prepare a site map, draw a 1/2 mile radius around the main building entrance, and projects with multiple buildings may draw a radius from multiple building entrances or one main. Schools, the radius may be drawn around any entrance. You want to mark all residential developments within the radius and mark all commercial buildings within the radius as well. The benefits include preventing suburban sprawl and less automobile use. This therefore reduces transportation impacts such as air pollution and greenhouse gas emissions, and increases physical activities, which is important in the broader impact of our built environment. There's a lot of focus on the health indoor our buildings, but also how we get to our buildings can affect our overall health. We'll hear more about indoor air quality in the environmental quality section. The trade-offs could include dense areas with limited open space and factors that could harm indoor environmental quality, such as contaminated soils, bad air quality, or limited daylight opportunities and less space for recycling storage. There's an exemplary performance point available if you satisfy option 1 and then one of the following requirements. Either the project itself must have a density at least double that of the average density within the calculated area, or the average density within an area twice as large as that for the base credit must be at least 120,000 square feet per acre. To build off the idea of more urban developments and more functions happening within our cities, vertical farms are one idea, actually bringing farming into our skyscrapers even potentially. There's a lot of discussions about this, especially in parts of the world where there aren't as many areas that are available for farming. But as our population grows, this becomes important in all parts of the U.S. as well. It's important to keep innovating how we're going to use our resources more wisely with the least amount of impact on the environment. Brownfield redevelopment is Sustainable Sites Credit 3. It's just 1 point for each of the different building types: new construction, schools, core and shell. Option 1 is to rebuild on a contaminated site as documented by any of the following, including ASTM E1903-07 Phase 2, an environmental site assessment, or local voluntary cleanup program. Option 2 is to develop on a site defined as a brownfield by a local, state, or federal government agency. In LEED version 4, draft 4, this credit is renamed in the location transportation section as high priority site. High priority sites would include federal empowerment zones, EPA national priorities list, federal enterprise community renewal areas, just as a few examples. In this way, you start to see social equity come into the picture of the rating system as well, really with the goal to revitalize a whole community beyond the site itself. The ASTM standard, which is the American Society for Testing Materials, includes a Phase 2 environmental site assessment criteria. Also, you can refer to the Comprehensive Environmental Response, Compensation and Liability Act and Superfund to potentially alleviate costs. There are 3 different ways to remediate a brownfield. One is ex situ, which is the least preferred. It occurs at another location, typically a treatment facility. It's a pump and treat system using carbon filter and incineration. More advanced version of this is chemical treatment or biological. In situ, it's better on site if it's done wisely. So treatment on site could include injection wells and reactive trenches. Could use natural hydraulic gradient groundwater, which only requires minimal disturbance of the site. Bioremediation is the best, utilizes microorganisms and vegetation to remove contaminants from water and soils. It's an alternative to landfilling and incineration.